Chapter 5 Control Freak. Just as we used the terms continuous and responsive to describe the ways that games communicate with us, we can also identify two major categories delineating the ways that we communicate with games. Direct input describes the mapping of a player's actions in the physical world to an action in the game world. In other words, if you press a button, something happens. Many of the actions available to a player are commonly defined in this way. Character locomotion happens as a direct result of moving an analog stick. Gunfire erupts from your weapon at the press of a button. Virtual input, on the other hand, is not direct. A virtual interface may serve as an intermediate between physical input and in-game action. Instead of directly resulting in action, player input manipulates a virtual interface, which then causes some in-game effect. For instance, managing a character's inventory might be supported through a virtual interface, where the mouse can be used to move icons representing carried items. In this chapter, we will examine how the design of control schemes and interactive interfaces dictate the way that players can communicate with games. When coupled with feedback, a game's input schema forms the other half of interaction between player and game, fundamentally affecting the game's experience. More design principles. We have already explored half of Norman's design principles: visibility, consistency, and feedback, in discussing how games communicate with players. The remaining three principles are of special interest to designing both direct and virtual means of player input. Before we investigate how these designs can succeed or fail, we will briefly examine the following principles and their meaning in game interaction: mapping, affordances, and constraints. Mapping is the relationship between the position of controls and their function. In games, mapping describes the layout of physical or virtual controls. While the physical location of buttons on a given controller is constant, different games can assign the function of those buttons differently, resulting in a different mapping. Virtual controls, on the other hand, grant designers total control over both location and function. The mapping of game controls has a significant effect on the user experience of a game's input system. Awkwardly positioned key bindings may lead to discomfort. In contrast, a well-designed control mapping will take advantage of ergonomics, leading to controls that feel natural. Well-designed things usually give you a clue about how to use them based on aspects of their design, such as shape. As an example, for humans, a handle on a porcelain mug affords grabbing. Based on design, we know that we can pick up the mug. To a cat, the use of porcelain, like many other materials, affords wanton destruction. In games, the concept of affordances usually means mimicking the design of real-world objects to hint at the function of virtual ones. Affordances are also present in the design of gaming peripherals. This thinking also applies to the design of virtual interfaces. Buttons must signal that they can be pressed in some way, lest they be mistaken for plain text. Proper use of affordances can help to guide the players while minimizing explicit instruction. For example, the presence of a lever, switch, or wheel in an environment hints at some machinery that can be interacted with. In playing a game, not all actions are always available. Constraints impose contextual limitations on the input that can be accepted at any time. The same action might be allowed or disallowed depending on certain contexts. There are several reasons why you might want to impose such limitations on players from time to time. Constraints can help prevent player error. They can also serve to enforce the game's rules by disallowing actions if they would be logically impossible in-game at the time input was made. Another application of constraints in games is to guide a player's experience according to a narrative or a predefined sequence of events. Good player input can be effectively summarized in three facets of successful designs: consistency, comfort, and customization. Executing just one of these aspects well does not promise the praise of game critics, but falling flat on any of them does all but guarantee that you will incur the wrath of your players. Consistency, a design principle we previously discussed in relation to feedback, is also of importance in the design of controls. External consistency, meaning consistency between different games, prevents conflict between your design and players' existing expectations based on their prior experience. Good external consistency generally adheres to the accepted conventions of a genre or platform, whereas poor external consistency violates these conventions without suitable reason. While external consistency will help to make sure that the onboarding process is as painless as possible for new players, internal consistency, meaning consistency within a game, is equally important. Performing the same fundamental action in different ways makes a system internally inconsistent, with no real justification for the disparity. Just as with external consistency, poor internal consistency breeds frustration. Executing inputs should feel comfortable, both in terms of physical handling and how these inputs feel in-game. The latter is largely a matter of technical fidelity, as controls should be responsive. On the design side, tweaking things like the acceleration of a character's movement can help to ensure snappy and responsive controls. Comfort in physical handling is related to hardware design, though it is also dependent on how our input mappings are designed. While an uncomfortable action lasting a few seconds probably won't make players toss a game for good, we must remember that players might be experiencing our games and its controls for hours at a time. What seems like a passable occasional awkwardness may quickly grow untenable. Customization can help compensate for shortcomings in consistency and comfort. All commands for direct input should be customizable wherever possible. Customizable controls can make or break an experience for players based on their prior experiences, preferences, or accessibility controls. Where players perceive a game to be externally inconsistent based on some mismatch in prior experience, customization can allow them to make a game reflect their expectations. Customization is not a panacea for every flaw in a game's input design, but it makes all the difference in a game's ability to suit the needs and preferences of different players. There are several different ways players can communicate their intent to a game. Traditional input refers to input methods that have been established in digital games of the past several decades. Touch input refers to input used for smartphones and tablets, and some consoles that feature a touchscreen. Motion-based input refers to both accelerometer-based motion controls and recognizing player movement directly through a camera. Other forms of input refer to novel forms of input, such as physiological sensors or voice control. These are not commonly employed, but it does provide interesting design opportunities. Rules of thumbstick. Direct input is just that. Input which translates directly to in-game action, without the need for interaction with some intermediary virtual element like an on-screen button. What makes a good direct input system varies to an extent based on its intended application. While there are many ways to distinguish applications of direct control, perhaps the most straightforward method of doing so is to ask what the player is controlling. Most games, particularly in the realm of PC and console titles, have you moving a character or vehicle of some sort. A well-designed character controller goes a long way towards pleasing players. The Mario series practically founded a franchise on satisfying controls. On the other hand, shoddy controls may not manage to put players off entirely, but can riddle a game's reception with words like sluggish, floaty, and unpredictable. Controlling a character comes down to designing for a few key inputs: character locomotion, camera movement, and actions performed by the character. We can further subdivide character controllers into three main variations: first person, third person, and controllers for unconventional character locomotion. In a first-person game, the player views the game world through the eyes of that character. Generally, moving the camera means moving your character's head. This makes mapping locomotion rather straightforward. Deciding what forward means is a no-brainer when your character is constantly facing the direction you are looking. Seeing the world through your character's eyes means that you might not be seeing very much of it. In a single-player title, this shaves off precious time, otherwise spent on full-body animations. Though sharing a pair of eyes with virtual characters comes with its share of unique design challenges. Things like mouse acceleration, y-axis inversion, and field of view can make an experience annoying or even nauseating if set improperly. Third-person titles position the camera such that players can see their character's body, ranging from over-the-shoulder views to situations in which the character's entire body is visible. Unlike first-person games, third-person games decouple character and camera movement. Camera movement may be mapped to its own input. Automatic camera controls are often preferable in 2D games, whereas in 3D most games opt to allow players freedom over camera movement. A challenge introduced in separating the player's view from that of their character is what it means to move forward. When the player nudges the left stick upwards, does the character move forward relative to the game's camera, or in the direction the character's model is currently facing? Another challenge is input delay as a result of character animations. Even a second or so of delay on something like a jump can make precision movements infuriating to perform. While the first and third person categories do cover all relevant possibilities for character control, it is worth placing unconventional controls into their own category. These types of games may have you controlling unconventional creatures, or even with a humanoid character, the control scheme may be far removed from what is the norm in first and third person games. Designing effective character controllers in these unconventional situations is challenging for a few different reasons. Players' learning of controls can't be supported as strongly by prior experience in other games. Furthermore, without an abundance of conventions to use as potential templates, development will become more costly as increased efforts in prototyping and testing are warranted. Lastly, it is harder to find examples which can be worked from. Designing a successful input paradigm within this category is a matter of some creative thinking. Strategy, simulation, and puzzle games often favor an omniscient perspective. Many titles in this category rely mostly on virtual input. In these cases, direct input is sometimes used as only a shortcut to accomplish something achievable through a virtual interface. The Sims is an example of a game that features an omniscient perspective. The abundance of virtual input in games like The Sims arises from both practical necessity and usability concerns. The game has a large possibility space which exists in normal play. Stepping back, consider a game that features direct input heavily in moment-to-moment gameplay, such as a first-person shooter. The basic interactions available at any moment boil down to a fairly small set. Contrast this with The Sims, where the player is issuing commands to a household of virtual people. Part of the complexity in games like The Sims is the sheer number of actions available to players at any given time. Relying entirely on direct input for something like interior decorating, for instance, is that there are not enough keys, buttons, sticks, or combinations thereof to encode every desired action. For these situations, direct input is best left as a shortcut for players' most frequent actions, rather than providing a mapping for every possible in-game action. Regardless of game context, a few key things guide the design process of any control scheme. First, determine which actions players will have direct control over. Then decide on the granularity of its representation. Will a single button press be adequate, or will it require more complexity? By this point, for any given action, you'll have a list of how many inputs you'll need to represent it. Your next step is deciding on a control mapping for each. For direct input, or designing a virtual interface element for virtual input. Lastly, how do these actions feel? Depending on the game context, all sorts of factors can contribute to the game feel of an action. All of these steps require design thinking and careful attention in playtesting. The process discussed here is something you will embark on time and time again in designing player input. Ideally, you should not be designing your game in a vacuum. One thing about people who play games is that they bring the summation of their past experiences with them wherever they go. By their very nature, conventions will be embedded in the experience of your players. Following conventions means that you can count on players to learn faster. It means that you can capitalize on muscle memory, creating harder challenges for players with the knowledge they will have practiced the skills that your game demands before even starting it for the first time. Following conventions to the letter is far from a golden path, however. Certain conventions are not very well suited for accessibility purposes. Another tricky element of working with conventions is that those conventions can be at odds with one another. Irrespective of potential pitfalls, sticking to convention as a template for control design is often worth it for the benefits it provides. Maintaining awareness of flaws such as inherently encoded biases and potential conflicts means that they can be mitigated with strategies like providing players with sufficient alternative options. That said, there's nothing wrong with breaking convention in the interest of creating something interesting or pleasant to interact with, so long as you can validate the pleasantness of that interaction in playtesting. A break in convention, whether by necessity or experimentation, is frequently the innovation needed to bring about a better standard as a new normal. Virtual input and two-way interfaces. So far, we focused a lot on direct input, where in-game consequences are a direct result of the player acting in the real world. Virtual input adds a layer of abstraction to the concept, with in-game consequences resulting from the player acting on some virtual element. You might call this indirect input in a sense, whereby a player's physical action only directly influences a virtual element which eventually leads to the desired action. We first introduced the concept of interfaces, facilitators of information exchange between players and games, in Chapter 2. Interfaces supporting virtual input are somewhat unique in that they support both forms of communication simultaneously. Virtual input elements don't just let players do something, they frequently tell the player something as well. Virtual input is ideal for situations with a significant possibility space, which renders direct input infeasible. It also works well in cases where conveying additional information to the player is preferable. Just as with HUD elements, we could define a few different categories for virtual input based on when elements are made available. For our purposes, though, it's easiest to simplify this distinction and talk about the degree to which virtual elements are embedded into gameplay. First, there's loose integration. Loosely integrated virtual input is that which is divorced from moment-to-moment gameplay. Most game menus fit this definition. Tight integration is when a virtual input interface does have a more immediate impact on gameplay. It is usually more tightly integrated. It lives close to gameplay and it is less disruptive to access during gameplay. Irrespective of how strongly a virtual input interface asserts itself as a part of gameplay, it is important to remember that all interfaces still affect player experience. Regardless of whether players are accessing something once or it becomes a part of their regular gameplay, interactive interfaces need to support interaction which is both usable and enjoyable. Just like HUD elements and sound effects, we can ascribe the equality of diegesis to elements of virtual input. Recall that if something is diegetic, it originates in a game world. and is something characters in that world would be able to perceive and/or interact with. Anything which exists outside the context of a game's world is said to be non-diegetic. The decision of whether to make an element of feedback diegetic is almost entirely aesthetic. The same cannot be said of the choice for virtual input elements. Here, there is an argument to be made that diegesis is sometimes necessary for an interaction to feel authentic. In games where a tightly integrated virtual interface is necessary to support gameplay, making those interfaces diegetic serves to boost immersion. Certain interactions might not make as much sense or feel unsatisfying if achieved indirectly by interacting with non-diegetic interfaces. Whether or not virtual input is diegetic, though, its design is plagued by a few common challenges. Chief among them is handling complexity. Virtual interfaces can easily become almost unsustainably complex. There's arguably no better case for the potential pitfalls of such complexity than the crafting menu, a bastion of sandbox games. If the options given to players via crafting are managed inelegantly, they can make navigating a game's crafting menu somewhat of a nightmare. The challenge here is to distill a lot of information into a more easily navigable format. From various game examples, such as Minecraft, we can derive a few key rules of thumb to guide the design of virtual input interfaces for optimal usability. Element visibility. When feasible, all the elements of a given virtual interface should be visible. Searchability. Interfaces where everything is visible at once are easily searchable from a quick visual scan, assuming reasonable element density. Frequency versus integration. The more frequently a player will need to perform a particular action, the more tightly integrated its virtual inputs should be. Shortcuts. Following similar logic, shortcuts via direct input or very tightly integrated virtual input should be provided for players' most frequent actions. And follow the rules of good communication. Remember that virtual inputs both allow players to communicate their intent while also providing some information about their function. Thus, their design should respect the tenets of good feedback. Functionality is king in the design of any interface. To achieve real enjoyment, something first has to be usable, whether that something is a HUD, a control scheme, or a menu. However, just because something is chiefly functional does not mean that it cannot be playful. As in designing game mechanics, art, or music, sculpting the way in which players interact with our games provides us with an opportunity to create an even better experience. Make sure to check out the book for more in-depth information on control schemes and interfaces. There you will also find an exclusive interview with Jason Avent, studio head at TT Games.